Section 12 is dedicated to defining and understanding distribution requirements planning as it relates to tying in forecasted and actual demand with purchase orders. And DRP, because it deals with finished goods, helps us to do just that. As we have stated on a number of occasions, DRP is associated with the sell side of a global supply chain and centers on the location, quantities, and timing of finished goods across a company's distribution network. It's important to stop here and point out and say that in the U.S., typically, not always, but typically an importer, depending on their size, is going to have more than one distribution point. They could have one, but it's difficult to cover the whole country. As such, it's typical to see, especially larger importers, very large importers, have 10, 12 DCs or satellite DCs across the United States. We're talking about the need for finished goods within the framework of DRP in each of those distribution nodes. Continuing on, second bullet point, as stated, the logic behind the determination of product quantities and timing in those DCs is equally applicable to distribution requirements planning, meaning that the concepts behind MRP are very similar, if not identical, to DRP. Last bullet, DRP was originally designed for the positioning of finished goods in a multi-warehouse distribution network. We spoke of that just a moment ago. Expanding our supply chain activities even further, sub-bullet here, it is now used, is DRP, to trace needs all the way up the supply chain to overseas suppliers. There's the tie-in. Finished goods out in the distribution network that are being consumed and purchased by customers. We need to get those signals all the way up the supply chain to suppliers. In the form of what? In the form of a purchase order. That's what we mean about the importance of DRP to tying purchasing into an integrated, holistic supply chain. Much like we saw with MRP, let's provide a technical definition of distribution requirements planning. As you can see right away, it's a little bit shorter than that MRP definition, but it's the same source, the APIX dictionary. Distribution requirements planning is the business function of determining the need to replenish inventory at branch warehouses. We said that, albeit less eloquently, in our previous slides, identifying how many warehouses, how many DCs in our U.S. distribution network we have, and when and in what quantities we have to have finished goods in each of those DCs to meet customer demand. The real trick here is, how do we use those demand signals, both forecasted and actual demand signals, to help translate demand into purchase orders on overseas vendors? That's why it's important to talk about DRP. Second sentence, a time-phased order point approach is used. We'll come back to that in just a bit, where the planned orders at the branch warehouse level are exploded via MRP logic to become gross requirements of the supply source. We're going to talk about order points in upcoming sections, but really what it means is that finished goods inventory is allowed to deplete down to a certain number, quantity of units, and based on cumulative lead time and the demand during lead time, order points are established. That definition can be a little confusing, but order point is about quantities. So if a quantity of a particular item gets down to 200 units, that's at the point when we place a replenishment order for that particular DC. Once again, we're going to get into order points in great detail, so don't worry too much about it now. But an order point isn't necessarily about time, it's about quantity of merchandise. How much we have left at a given moment, how long will that last, and can we time the arrival of new merchandise before the existing merchandise runs out? Don't worry too much about order point right now. We're going to get to it in an upcoming section, and we'll get to it quickly. But do focus on a time-phased order point approach where we have to plan for orders of finished goods to be located at specific branch warehouses or DCs. That MRP logic is about gross to net exploding, which we've talked about. What's our gross requirement in each period? And subtract what we're going to have on hand from that gross amount to get to our net amount. That's what we're talking about there. That's where this MRP logic is the same for DRP. More on that later. A little bit further elaboration on DRP. The short definition is that DRP logic calculates time-phased requirements in specific quantities. There it is again, quantities and time, over a planning horizon, maybe a year, maybe a quarter, and by time buckets, typically a week. To be clear, DRP is intended for independent demand items, finished goods, totally different from MRP, which is dependent demand for raw materials. Naturally, DRP is heavily influenced by actual demand signals from our omni-channel distribution model, stores, online sales, customer orders, etc. We can see a lot of similarities between DRP and MRP. It's just really all about, in a DRP environment, having finished goods at a distribution point in the US when we need them, and being able to trace inbound activities all the way to the origin purchase order that is placed on the overseas vendor. That's a holistic supply chain. Much like MRP, DRP starts out by calculating gross requirements by time bucket, oftentimes based on a forecast. We're going to see that in an upcoming example. Of equal, if not greater importance, there are several drivers of gross requirements, and of course, getting to a net requirement. Beginning on-hand inventory by item. What do we have already in those warehouses, in those DCs around the country? How does that quantity line up with our forecasted sales for those goods? What impact are customer orders going to have not only on the forecast, but on the on-hand quantities and what we can allocate to customers? Any backlogs of open customer orders that we've received but don't need to be fulfilled until a period out in the future, but we have to contemplate them as well. And then any inter-network supply orders. Little tricky, but that's a scenario where a U.S. importer will have multiple distribution facilities in the U.S., and a smaller, perhaps satellite warehouse is placing an order on a larger regional distribution center. That's what we mean by inter-network supply orders. And the more complex a distribution environment becomes in the United States in terms of number of locations, the more tricky, the more difficult DRP becomes. As a trade tip, and this sets the stage for subsequent conversations on the subject, similar to the MRP logic, the truly important number by time bucket is what's referred to as projected on hand. What do we think we're going to have of item-specific finished goods out into future time buckets? And how do we make adjustments if we don't have enough or if we have too much of that particular product? Couple more slides in this section. DRP calculations have to generate specific outputs. Number one, projected on-hand amounts by time bucket. We already said that. But also, and this has to do with the purchasing side of things, how goods are coming into the DCs from overseas. Planned order receipts by time bucket based on what? Cumulative lead times. What can we plan on receiving out into the future? Because we know we have purchase orders placed on vendors. And then any planned order release by time bucket. A planned order release being an order within our own distribution network to get goods out to the DC that needs it, assuming that there is more than one DC in the network. DRP software, which is in existence just like MRP software, also generates action messages. And this is the advantage of digitizing a supply chain, because manually this becomes really hard. DRP is going to tell us when to release a planned purchase order. If we know we need a certain amount of goods 180 days out in our distribution network, and we have a 180-day cumulative lead time with an overseas vendor, the system is going to tell us right away that a purchase order has to be placed. DRP will also tell us if lead times are out of sync, that whole idea of cumulative lead time. We need something in 180 days, but the cumulative lead time, goodness forbid, is 200 days. That's a long time, but it's exemplary of what we're talking about here. Are lead times out of sync? Do we need to expedite a scheduled receipt because the system is telling us we're not going to get it in time based on that cumulative lead time? Do we have to switch from ocean freight to air freight, for example? Or in the U.S., do we have to go from standard truck service to a team driver service to get goods where they need to be quicker? Should we de-expedite a scheduled receipt? We don't need a product as quickly as we thought. Can we not use air freight? Can we use standard truck freight? That type of thing. And then maybe, if goods aren't selling as well, cancel a purchase order. So these software capabilities will generate action messages, which ultimately find their way upstream in the form of purchase orders on overseas vendors. Last slide in this section. PO timing and quantities. Using DRP as not the only tool, but certainly an important tool in making those timing and quantity determinations. DRP tactics help purchasing, because that's the whole theme here. How can DRP help purchasing and supply chain professionals to answer a series of very important questions during a specific planning period? Pretty common sense stuff, but not so easy to do out in the field. What do we need? What products will we need in future time buckets over a given planning horizon? In what quantities will we need them? In what DC will they be needed? In what distribution center? Especially if we have more than one in the US, which most companies do. When do the needed products need to be in-house? Meaning in a specific DC to meet customer demand. And in the spirit of going from a gross requirement to a net requirement, will we have any product-specific inventory on hand already? That's the difference between a gross requirement and a net requirement. Meaning, if in period 50, we're going to need 1,000 units of a product in the DC in Minneapolis, but the system is telling us we're going to have 500 units on hand anyway, the gross requirement is 1,000, but if the plan is to have 500 on hand, the net requirement is 500. That is what gross to net exploding is. All of these questions have to be answered by DRP and used by purchasing to make acquisitions of product in the right quantities and at the right time. That's it for this section. When we come back, we're going to revisit a slide that you should all recognize. This time, within the context of how DRP signals cascade up the supply chain to overseas suppliers.